I'm going to go over question 7 from the corbettmaths vectors questions. Okay, these are quite challenging. So let's have a look. We've got this shape, and we know that AOB is a triangle, okay, and P is a point on OA. It's kind of obvious from the picture. And then we've got that AB is 2A, so I'm going to write that down so that I can keep track of what we've got. So AB is 2A, and AO is 6. So I'm going to draw an arrowhead to show which way we're going. AO is 6B. Okay, and our first question is find the vector OB in terms of A and B. So when you think about where we're heading, we're trying to get from O to B. Now we don't have any letters on there that we know about. We haven't got an A or a B. So we look for a route that takes us along the A's and the B's, but still starts at O and ends at B. So if I start at O and go to A, I'm fine, there's a B on there. And then I start at A and go to B, and I've got to my destination, and I've gone past an A. So now that means that we can figure out how to write OB in terms of A and B. So OB is equal to OA plus AB. And OA is going the opposite direction from AO, so it's minus 6B, okay, and AB is 2A. There we go, that's it. Right, the next part's the tricky bit. So we're given lots more information. AP to PO is in the ratio 2 to 1, so I might write that on there as, so A to P is the 2 bit, so this is like 2/3. And P to O is 1/3, so it's in the ratio 2 to 1. So that means if AO is 6B, then this must be, because 6B is split in the ratio 2 to 1, this must be 4B to get from A to P, and 2B to get from P to O. Okay? Right. We're also told that Q is the midpoint of OB, so we've got halfway along, and B is the midpoint of AC. So if B is the midpoint of AC, that means A to B is the same length as B to C, and so we could put that B to C is also 2A. Right, our task is to show that P, Q, and C is a straight line. Let's just have a look at that. So we're going P, Q, and C. We've got to prove that that's in a straight line, even if it isn't quite right. Okay, right. For that to be true, then we can, for example, get from P to Q and from P to C and show that they've got the same kind of vector. One's a multiple of the other. Okay, because that would mean they kind of have the same gradient. Or we could go C to Q and C to P, whichever we want to do it. I'm going to go P to Q and P to C. So let's go with PQ. Alright, how am I going to get from P to Q? So I'm going to go from P to O and O to Q. Because P to O we've already got, and O to Q is just half of O to B. Okay, so P to O is 2B, and O to Q is going to be half of our answer for O to B. Okay, so we've got 2B, and then a half of minus 6B plus 2B. So we've got 2B, and that will be minus 3B plus A. So altogether that will give us A minus B. So that's PQ. So now what we need to do is find PC or QC. Alright, so I'm going to have a little look at QC because that looks alright to me. Okay, let me just see. Let me just move the question a bit out of the way so we can see. So we've got Q to C. easy route will be going Q to B and B to C. Okay, now Q to B is, because Q is the midpoint, that's going to be the same as a half OB, and we know that a half OB is minus 3B plus A. Okay, and then B to C, we've already worked out, is 2A. Right, so if we add those up, we get minus B plus A. Alright, or A minus B. So now we know that PQ and QC are actually the same vector, so then definitely one is a multiple of the other. I'm going to just write that down to make it clear. So we've got that PQ is equal to 1 times QC. Okay, so that means that they have the same direction. But also, they have a point in common. So because the point Q is in common, then it means that PQ and